Okay, we're still practicing alkanes. They tried to break us with the first few. Now they get increasingly difficult, and there's a stunning number of these, which is great for practicing. But it means that this is going to be a bit of a marathon recording, so I'm going to go at a moderate clip. I'm going to try to keep the explanations sufficient, but I hope that I can keep the level of detail at a level that gets us through this without it taking too long. And let's see if I can get through all of these without making any mistakes. So remember that our drill is always to start by trying to find the primary chain, the longest path through the entire thing. And I'm not going to show a lot of alternatives because that burns up too much time, but I don't think you will do better than this for the primary. 1, 2, 3, 4, 5, 6, 7, 8, 9 makes this nonane. Attached to it are two methyl groups. Let's change colors. Two methyl groups makes it dimethyl nonane. And where are they? 1, 2, 3, 4, 5, 6. It could be 3,6 dimethyl nonane, or going the other way, 1, 2, 3, 4, 5, 6, 7. 4, 7 dimethyl nonane. Nope, the 3,6 is better. The first number you see in the molecule should be as low as possible. Next, for a primary, 1, 2, 3, 4, 5, 6, 7, and then these two is the longest path. Okay, so all that is our primary. 1, 2, 3, 4, 5, 6, 7, 8, 9, nonane again. And what's attached to it? A methyl group, another methyl group, and another, and another. This is tetramethylnonane. And where are those methyl groups? Starting from here, 1, 2, 3, 4. Let's see. Okay, this one's complicated because there's threes in either way. You can either go 1, 2, 3, 4, 5, 6, 7. So it could either be 3, 3, 4, 7 if I count from the right, or if I count from the left, 1, 2, 3, 4, 5, 6, 7, 7. So the first one is a 3 no matter which way you count, but after that, 3 versus 6 means this is the way that you count it. Notice when there are two methyl groups on the same atom, you repeat that number. So 3, 3, 4, 7 tetramethylnonane. Even if there were just these two branches, you'd say 3, 3 dimethylnonane. So saying that number twice is how you let them know the two methyl groups are attached to the same thing. So 3, 3, 4, 7 hyphen tetramethylnonane. Okay, and down here, 1, 2, that's primary for sure. And down here, you could technically take any one of these carbons as the last one of your primary. I'll take the one that makes the straightest line. I find that easier to visualize. 1, 2, 3, 4, 5, 6 makes it hexane. Our primary is a hexane. What's attached to it? 1, 2, 3, 4 methyls again, so again tetramethyl. And where are they? 2, 2, 4, 4. If we count from the left, it's 2, 2, 4, 4. If we count from the right, 1, 2, 3, instantly loses. That's a higher number than this, so 2, 2, 4, 4 is correct. 2, 2, 4, 4 tetramethylhexane. Okay, what now? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that the longest one? 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this section is the longest chunk on the left, and on the right we have 1, 2, 3, 4, 1, 2, 3, 1, 2, yeah. That pretty much horizontal one is our primary. 1, 2, 3, 4, 5, 6, 7, 8, 9 makes it nonane. What's on it? All kinds of stuff. We have a methyl group. We have an ethyl group. And we have, what's 3? Me eat peanut butter. P is for the third one, so propane, propyl. We have a methyl group, an ethyl group, and a propyl group. So how do we organize those? You remember? Alphabetical order. Nonane goes at the end, of course. The rest of these go alphabetized, so it'll be the ethyl, and then P is after M. Can I fit all this in there? Need a little more space. Pull that over. There we go. Ethyl, methyl, propyl, nonane. And what's missing? The numbers. So the ethyl group, because it's first in alphabetical order, is going to determine our numbering for us. Probably. Which carbon is this? If we start from the left, 1, 2, 3, 4, 5. If we start from the right, 1, 2, 3, 4, 5. Rats. Okay, the ethyl isn't going to determine our numbering. It's 5-ethyl no matter what. So we still haven't decided if we're counting from the left or right because it's 5-ethyl either way. Okay, methyl, you're second in alphabetical order. Will you decide for us? From this end, 1, 2, 3, 4 methyl, or 1, 2, 3, 4, 5, 6 methyl, 4 wins. So our numbering is from the right. I don't know if you need to see the numbers like this, but it is now official that our numbers go from right to left. I'll put that in just to show it once. Okay, so 1, 2, 3, 4 methyl, 5-ethyl, 4 methyl, and where does that make the propyl? 1, 2, 3, 4, 5. Squeeze. Okay, 5-ethyl, 4 methyl, 5 propyl, nonane. No problem. Okay, where's our primary here? I'm looking at this and this. I think they're equal length, though. You got 3 here. Or this. If we continue this way, 1, 2, 3, 4, 5, 6, 7, if we go to that end. If we go to this end, 1, 2, 3, 4, 5, 6, it's 7 no matter how you do it. Okay, but here's something. This is the first time this has come up, so I'm actually glad this happened. If you call this your primary, and we're not going to, here's where you get into trouble. You would then have a branch over here which has its own branches, and that for now is death. We cannot handle that. We don't know how to name things that have branches with other branches coming off of them. I actually don't know how to do that either, so we'd be in a lot of trouble if we did our primary that way. You have to have a single primary, a single trunk that's got all the branches coming off it. So that means it's pretty much mandatory that we take our primary this way. There. Now we have a primary that just has nice single branches coming off it in every direction. So that's the best choice for our primary. And that primary is 1, 2, 3, 4, 5, 6, 7 carbons long, which makes it a heptane. Now, what's on it? Methyl group, and another methyl group, and another methyl group, so it's going to be trimethyl. Numbers coming up in a minute. What else is on it? 3 carbon branch over here, that's propane or propyl. Now, you put these in alphabetical order. Do not count the prefix. You don't put this, you shouldn't be saying P comes before T, therefore propyl comes first. You should be saying M for methyl comes before P for propyl, therefore the methyl goes first. Ignore the prefixes and just concentrate on the actual group names when you are alphabetizing these things. So it's trimethylpropylheptane. And the last thing we need is the carbon numbering. If I count from this end, then this is 2 It's going to be 2,2,4 trimethyl. One of our choices is 2,2,4 if I count from this end. If I count from this end, 1, 2, 3, 4, and then 6, yeah, 2,2,4 is better. Lowest leading number. So 2,2,4 trimethyl, and what does that mean for the propyl? 1, 2, 3, 4 for the propyl. 2,2,4 trimethyl 4-propylheptane. All right, what now? This is clearly our primary all the way up to here, and then you can have 2 carbons this way or only 1 if you go to the right. We will take the 2. So that's our primary chain, and it is 1, 2, 3, 4, 5, 6, 7, 8 carbons long. That is octane, gasoline. And what's attached to it? A single methyl group. So this is methyl octane. Where is that methyl group? Counting from this end, 1, 2, 3 methyl octane, or from the other end, obviously more, 1, 2, 3, 4, 5, 6 methyl octane. We'll take the 3, thanks. This is 3 methyl octane. Okay, what do we have here? 1, 2, 3, 4, 5, 6. Yeah, there's no way to get more than 6. That's our primary. These H's drawn like this are really distracting, but try to ignore them. Carbon is really all we care about for now. You could have made this your primary chain also go that way and then down, but as usual, I'll make my primary a straight line whenever I get a chance. So 1, 2, 3, 4, 5, 6 carbons makes this a hexane. What's attached to it? A methyl group and another methyl group. 2 methyl groups is dimethyl hexane. And what numbers are they on? This is carbon number 1. Number 2 has a methyl group. Number 3 also has a methyl group. So this is 2,3-dimethyl hexane. 2, 3 hyphen dimethyl hexane. Okay, this last thing, again, I can't visualize these unless I write the carbons in. If you can, terrific. There's a part of your brain that works better than mine, but that's what I get. And so for our primary, you could go that way or that way or that way. All those primaries are 3 units long, so I'll just randomly take one of those. This is 3 carbons, which makes it propane. Clean, efficient propane. Attached to it is a methyl group, which makes this methylpropane. Now, funny thing about this name, you're waiting for me to do numbers, and I'm going to, but I claim that you could just say methylpropane and you would be all right. Ponder that for a second. Well, if we do the numbering from either end, we get, if we go this way, it's 2-methylpropane, or if we do this way, it's 2-methylpropane. So you could say 2-methylpropane, and I don't think anyone would criticize you, but why is this 2 kind of unnecessary? The other possibilities are either it's 1-methylpropane, or, well, we wouldn't say 3-methylpropane because that's a higher number than this, but 1-methylpropane doesn't exist. Do you see why not? Here's what that would mean. It would mean draw propane, 3 carbons. Now, on the first carbon, attach a methyl group. Well, what is that really? It's 4 carbons in a chain. It's butane. You would never see 1-methylpropane because this is just a silly, thoughtless way to describe a 4-carbon chain, which we'd call butane instead, meaning this should never happen. Meaning if you have methylpropane, the only thing it could possibly be is this kind of T or Y shape. Ergo, this 2 here is sometimes excluded. I don't want to say optional. I'm going to say sometimes omitted. So I'm going to say that the correct name for this is 2-methylpropane, but don't be surprised if you see that 2 just dropped and someone will just say methylpropane. If that happens, it probably means, if you think carefully, there's no number that would possibly make sense except for 1. Or, I mean, there is only a single number that would make sense in that context. That's usually what's going on. Sometimes it's human error, but usually it's they've thought carefully about the possibilities and found that since 2 is the only number that could possibly go here, they're not going to waste time writing it. That will probably come up again. Oh, look, what do we have here? Line diagram again, so here I am putting in the carbons. Okay, our longest path through this, I believe, is in a zigzag like this. That gets us 4 carbons in our primary chain, and 4 carbons is butane. What's attached to it? A methyl group and another methyl group, so this is dimethylbutane. And where are they? Carbon number 2 and carbon number 3. So 2,3-dimethylbutane. This one's pretty straightforward, I think. Primary chain, nice and straight. 1, 2, 3, 4, 5, 6, 7 carbons makes this heptane. There is a methyl group, so it's methylheptane. That methyl group is on carbon number 3, so 3-methylheptane. Counting from the other end, it would have been like 5, so way too high. Here, I think this way is our longest primary. In theory, either of these could be your primary too if you like bendy primary chains. I'll pass on that. 1, 2, 3, 4, 5, 6, 7, 8, 9 is nonane. What's attached to it? Methyl, 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 methyl. So we have tetramethyl. We also have a 2-carbon chain here, which is an ethyl. So I need a little more space to get this down. Nonane is our primary chain. Ethyl comes before methyl in alphabetical order, so ethyl tetramethyl nonane. And what are the numbers? For the ethyl group, 1, 2, 3, 4, 5 if we count from the left, or 1, 2, 3, 4. It's 5 either way, so the ethyl is refusing to help us. It's 5-ethyl no matter which end we count from. How about the methyl groups? Well, we can have 2 counting from this end, or the first methyl group is on carbon number 3 counting from the right, so we will count from the left. This will be carbon number 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's 2 methyls on carbon number 2, so we're going to have, I need a little more room for all these methyl groups. 2, 2, and then we have 4, and carbon number 4 has a methyl group, and so does carbon number 7. 2247 and little dash in there. 5-ethyl 2247 tetramethyl nonane. Just rolls off the tongue, doesn't it? Getting close to the end. We hope. What do we got here? 1, 2, 3, 4, 5 carbons makes our primary pentane. This is a methyl group, so is this, so it's dimethylpentane. And where are they? Whichever way you count, they're both on carbon number 3, so it's 3,3-dimethylpentane. For this, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we go right through the middle, that should be our primary. There's 2 carbons here, 2 this way. Yeah, you could use this as your primary, but As usual, I'll go with the one that's easier to read. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just making sure. Makes this nonane. What's attached to it? We have methyl groups and an ethyl group. So let's anticipate here and do our alphabetical order thing. Ethane first. This will be ethyl. And then we have 1, 2, 3 methyl groups. So trimethyl. I hope you can follow this without the color coding. That slows me down a little bit. So I did it for the first few, and now I'm slowly getting away from it. But I hope not having the corresponding colors isn't making this too bad. Eventually you'll be doing this just with a pencil, so we'll get better at reading these, we hope. So our ethyl group gets to decide which way our numbering goes. From this end, this would be 3 ethyl. From the other group, 1, 2, 3, 4, 5, 6, 7 ethyl. So yeah, we'll be counting from the left. 3 ethyl. And then where does that make our methyl groups? There are 2 on carbon number 2. So 2, 2. And we also have one on carbon number 1, 2, 3, 4, 5, 6. 3 ethyl 2,2,6 trimethyl nonane. And last one. Nice obvious primary. 1, 2, 3, 4, 5, 6, 7, 8. Again with the nonane. What's on it? An ethyl group. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, the ethyl is dead center, so it's going to be 5 ethyl no matter which way we count. How about the methyl? 1, 2, 3, 4 if we go from this side, or it's going to be like 6 from the other side. So 4, 4 dimethyl nonane. Last one. Tragically, they're all line diagrams, so I get to draw in all these C's. C, C, C. The end of every line, in other words, every corner, is a carbon atom unless it's specifically labeled as being something else. Let's do all these while we're at it. Let's try to keep it looking a little bit like a letter C there. Okay. So I think I feel like our primary is top left to bottom right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Going that way. Is there any way to get more than that? No, I don't believe there is. So 4, 5, 6, 7, 8, 9. That is our primary. It's got 9 carbons, therefore this is nonane. What's attached to it? An ethyl group, an ethyl group, and an ethyl group. So this is triethyl nonane. And where are those ethyl groups? If we count from the left, 1, 2, 3, 4, 5, 6 triethyl nonane. So coming from the left, it's 4, 5, 6. If we count from the right, is it the same thing? 1, 2, 3, 4, 5, 6. Yeah, it's 4, 5, 6 triethyl nonane no matter which end you count from. This molecule is symmetric. All right. How about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. Nonane strikes again. Okay, we have, this is an ethyl group, This is a methyl group. In alphabetical order, the ethyl comes first. So this will be ethyl, methyl, ethyl methyl nonane. And now we just need numbers. Ethyl, will you help us this time? If we count from the left, 1, 2, 3, 4, 5, 6 ethyl. If we count from the right, 1, 2, 3, 4 ethyl. So it is decided we will count from the right, which means this is carbon number 1, this is number 2, this is number 3, so it's 3 methyl. And there we go. Nonane with an ethyl on the 4th carbon and a methyl on the 3rd carbon. And what's going on here? 1, 2, 3, 4, 5, 6, 7, 8, 9. This can be our primary. Yep, nonane once more. And what's attached to it? A methyl group, another methyl group, and another methyl group. 3 methyls means trimethyl. And what carbons are they on? They're clearly all huddled towards the left end, so I'm going to be counting left to right. It's going to be number 2, number 3, not number 4, and number 5. So 2, 3, 5 trimethyl nonane.